Hello everyone. Now I am going to start your first chapter of mathematics, class 7. Your first chapter is integers. So first of all, we all have to know what is integers. Integers. All natural number zero and negative of natural number are called integers. All natural number starting from 1 to infinity, 0 and negative of all natural number are called integers. Second, properties of multiplication on integers. First, closure property. The product of two integers is also an integer. As example, if you multiply minus 2 multiply 3, then result is minus 6. Here minus 2 and 3 are both integers and the result minus 6 is also an integer. So the product of two integers is also an integer. It is called closure property. Second, commutativity. If A and B are two integers, then A multiply B is equal to B multiply A. As example, 2 multiply 3 is equal to 6 and 3 multiply 2 is equal to also 6. So here 2 multiply 3 is equal to 3 multiply 2. So it satisfies the commutativity property. Third, associativity. If A, B and C are any three integers, then A multiply B multiply C is equal to A multiply B multiply C. As example, if 2 multiply 3 multiply 4 is equal to 2 multiply 4 3 is 12, result is 24, and 2 multiply 3 in bracket multiply 4, 2 3 is 6 multiply 4 is equal to 24. So here 2 multiply 3 multiply 4 is equal to 2 multiply 3 multiply 4. It satisfies the associativity property. 4. Distributivity of multiplication over addition. If A, B and C are any three integers, then A multiply B plus C is equal to A multiply B plus A multiply C. As example, 2 multiply 3 plus 5. First of all, we have to add 5 and 3. 5 plus 3 is equal to 8. 2 8 is 16. and 2 multiply 3 plus 2 multiply 5. 2 3 is 6 plus 2 5 is 10. 10 and 6 16. So 2 multiply 3 plus 5 is equal to 2 multiply 3 plus 2 multiply 5. So it satisfies the distributivity of multiplications over addition. Third, existence of multiplicative identity. If a is any integer, then a multiply 1 is equal to 1 multiply a is equal to a. So the integer 1 is called the multiplicative identity for integers. Existence of multiplicative identity. If a is any integer, then a multiplied by 1 is equal to 1 multiplied by a is equal to integer itself. So the integer 1 is called the multiplicative identity for integer. 4. Additive inverse or negative of an integer. If a is any integer, then minus a is called the additive inverse or negative of an integer. As example, if you have to write the additive inverse of 2, so if a is any integer, then minus a is called the additive inverse or negative. So here we have to write the additive inverse of 2. So additive inverse of 2 is equal to minus 2. Additive inverse of minus 2. Then we write minus 2 in bracket. Minus plus 2. Find if a, b and c are integers such that a greater than b, then first a multiplies c is also greater than b multiplies c if c is positive. A multiplies c is less than b multiplies c if c is negative. Six, properties of divisor. First, if a and b are integers, then a divided b is not necessarily an integer. If a is an integer different from 0, then a divide a is equal to 1. For every integer a, we have a divide 1 is equal to a d. If a is a non-zero integer, then 0 divide a is equal to 0. E, if a is an integer, then a divide 0 is not meaningful. Properties of division. First, if a and b are integers, then a divide b is not necessarily an integer. Second, if a is an integer different from 0, then a divide a is equal to 1. That means if you divide any integer by itself, then our result is 1. For every integer a, we have a divide 1 is equal to a. That means if you divide any integer by 1, then the result is the integer itself. If a is a non-zero integer, that means the 0 is not a include in non-zero integer. So 0 divide a is equal to 0. If a is an integer, then a divide 0 is not meaningful. So that means if here we do not divide any integers by 0. No. First, 0 is an integer which is neither positive nor negative. Second, on a number line, all numbers to the right of 0 are positive integers, and all numbers to the left of 0 are negative integers. It is a number line. In middle we denote 0. On a number line, all numbers to the right of 0 are positive integers. It is right of 0. So we denote it by positive integer 1, 2, 3, 4, 5, etc. It is left of 0. We denote here minus 1, minus 2, minus 3, minus 4, etc. Third, 0 is less than every positive integer and greater than every negative integer. 0 is less than every positive integer and greater than every negative integer. That means 0 is greater than every negative integer. Two integers that are at the same distance from 0, but on opposite sides of it are called opposite numbers. That's all. That is the theory of chapter 1. Now we start exercise 1.1. Exercise 1.1. First, 12 multiply 7. Here we have to multiply. So 12 7s are 84. That's it. Second, first, we have to multiply 3, multiply minus 8, multiply 5. Here plus, minus and plus. So both plus and plus are multiplied, we get plus and minus when multiplied, then we get minus, and then 8 3 are 24 and 24 5 are 120. Third, first, we have to find the value of 1487 multiply 327 plus minus 487 multiply 327. Here we have two terms separated from the sign of plus. We take common 327 in both terms. Then we have 1487 from first term and minus 487 from second term. Now we have 327 multiply. We have to minus 1000. So the answer is 3,27,000. We have to solve question number 4 by yourself. Question number 5. First, determine the integer whose product with minus 1 is 58. We have to write an integer whose product with minus 1 is 58. An integer whose product with minus 1 is 58 is equal to. Now we divide that number by minus 1. 58 divided by minus 1. What is the result? Result is minus 58. So integer whose product with minus 1 is 58 is equal to minus 58. 6. First, what will be the sign of the product if we multiply together 8 negative integers and 1 positive integer? Sign of product when we multiply 8 negative integers and 1 positive integer. So first of all, we have to know that what is the sign of 8 negative integers when it get multiplied. So if the number of negative integers is even, then the sign of is plus. If the number of negative integers is odd, then the sign is minus. So here the number of negative integers is even. So the product of 8 negative integers, we get the sign of plus, and 1 positive integers multiply plus. So plus multiply plus is equal to plus. 7. First, state which is greater 8 plus 9 multiply 10. Firstly, we have to add 8 and 9. Result is 17 and multiply 10 is equal to 170. And 8 plus 9 multiply 10. Then we have to 8 plus 10 is 90. 98. Here 170 is greater. So 8 plus 9 multiply 10 is greater. Now question number 8 first. A multiply minus 1 is equal to minus 30. Is the integer a positive or negative? First of all, we have to find the value of A. So A equal to minus 30. Here minus 1 is in the sign of multiplication. So when we interchange the minus 1 on opposite side, it gets on the sign of divide. Minus 30 by minus 1 is 30. So the sign is plus. So we write A is positive. Question number 9 first. Verify the following. We have to write LHS. Left hand side. 19 multiply 7 plus minus 3. 19 multiply 7 plus minus 3. 19 multiply 4. Answer 76. RHS. 19 multiply 7 plus 19 multiply minus 3. We have to multiply 19 and 7. So 19 7 is 133 plus minus 93 is 57 is equal to 76. So LHS equal to RHS. Very fine. Now we get on exercise 1.2. Question number 1 first. Divide 102 by 17. So we write 102 by 17. 17 6 102. The result is 6. On question number 6. Divide minus 729 by minus 27. So we write minus 729 by minus 27. Minus and minus 7 gets eliminated. 27. We have to cut by 3. 3 9 is 27. 243 3 is 729. 3 3 is 9. 3 8 is 24. 3 1 is 3. And 27 3 is 81. The result is 27. Second first. Fill in the blanks. 296 divided by what is equal to minus 148. So on the place of fill in the blanks we write x. 296 multiply. Here x means x by 1. So we get, when they interchange the sign of divide in multiply, we write here 1 by x is equal to minus 148. By cross multiplication, minus 140x minus 148x is equal to 296. X equal to 296 by minus 148. 148 to the 296. Here the sign of negative is in denominator, but we write the sign of negative is in numerator. So answer is minus 2. That's all. We have to solve all left questions of exercise 1.1 and 1.2 by yourself. On our next video, we discuss about exercise 1.3, 1.4 and other exercises. Thank you.